Hello, in today's video we're going to be talking about polyatomic ions. So these are different than the binary systems that we have been previously talking about. For the ionically bonded systems, we saw a single element of a metal bonding to a single element of a nonmetal. For our binary covalently bonded compounds, we had a single nonmetal bonding to a separate single nonmetal, and they were covalently bonded. Here, for those of you who have taken Latin and Greek roots, we can break down this word, polyatomic. Poly means many. So this is a many atom ion. So we know from our metals to nonmetals, our ionically bonded systems, something's going to have to either gain an electron or give up an electron for it to be considered an ion. Same thing is happening here. Each one of these compounds is going to have either given up an electron or multiple electrons, or gained an electron or multiple electrons. So these are the 7 polyatomic ions that I want you guys to memorize. You should be able to memorize these fairly quickly. There's only 7 of them. I'm also going to give you a sheet on our lecture notes that has about 15 or 16 other polyatomic ions that we will be using in class, but these are the only 7 that I will be quizzing you on and testing you on. These are the main 7 that come up regularly in general chemistry. So let's go through this. Let's see how this is done. The first one I want to talk about is ammonium. This is the only one of the 7 polyatomic ions that will have a positive charge. What that means is the overall compound is going to have given up an electron. So let's see how what this molecule looks like. It's going to be a nitrogen bonded to 4 different hydrogens. This is a covalently bonded system. All the electrons are being shared between the nitrogen and the hydrogens, and there's just a sea of electrons. This could not be considered an ion yet because it doesn't have a charge in the upper right-hand corner. Since these are all polyatomic ions, this has to have a charge associated with it. And for ammonium, it's going to have a positive charge. That means that the covalently bonded system of nitrogen and hydrogen, the overall sea of electrons, you're going to have lost a single electron. Not only will you have to remember the name of each of these polyatomic ions, you'll have to know the formula and the charge. So there's only 7 of them. I recommend flashcards, but these are the 7. Okay. So this is the only one that has a positive charge. Let's go to hydroxide. Hydroxide is also a special polyatomic. Anytime you hear the word hydroxide, your brain should automatically think it's a base. We haven't talked about what bases are, but just for right now, it's a base. Sodium hydroxide is a base. Magnesium hydroxide is a base. Aluminum hydroxide is a base. Anything with the word hydroxide in it is going to be considered a base. So what is this magic hydroxide? It is going to be a covalently bonded system between oxygen and hydrogen, and the overall compound is going to have a negative charge. What that means is that the system of oxygens and hydrogens, you're going to have gained an extra electron. That's where this negative comes from. You should be able to calculate and determine how many electrons are present in a polyatomic here, because we know how many electrons are on a neutral oxygen. We know how many electrons are on a neutral hydrogen. We just add an extra electron to make this a negative. So you should be able to do that. We'll do a few in class tomorrow. Let's move on to chlorate. Chlorate doesn't regularly come up too much in general chemistry, but it is one that's kind of out there. We'll see it a few times. Chlorate is going to be between a chlorine and an oxygen. And 3 oxygens. This is a covalently bonded system. The overall chlorate polyatomic ion is going to have a minus charge. So here we can see where that many atom, the poly atom, came from. There's a total of 4 atoms here. There's a total of 5 atoms here. That's many different atoms for a given compound. Each one of these is going to be considered a covalently bonded system for what's written down here. Okay, so remember that. Nitrate, this is going to be between a nitrogen and 3 oxygens. This is also going to have a -1 charge. Nitrates are salts, a lot of salts. Sodium nitrate, magnesium nitrate, a lot of salts. We will be dealing with nitrate a lot in this class, so that should be one that should be in your memory. Carbonate, calcium carbonate, which I'm holding in my hand, chalk, is made up of this carbonate plus calcium. So what is this carbonate? This is going to be a carbon covalently bonded to 3 oxygens And unlike the rest, where all these are plus or minus 1, the carbonate will be our first one that has a 2- charge. That means the covalently bonded system of carbon and oxygen, of those 3 oxygens and 1 carbon, will have gained 2 electrons from somewhere. So we'll talk about where those come from tomorrow in the class. Phosphate. This is the only polyatomic that we will discuss that has a 3- charge. You can see the trend here. Chlorate, chlorine. Nitrate, nitrogen. Carbonate, carbon. Phosphate, we can guess that there's going to be a phosphorus there. So this is going to be a PO4 3-. So that's going to be a phosphorus covalently bonded to 4 oxygens with a 3- charge. And then sulfate, following along with the trend, this is sulfur, so it's going to be SO4 2-. Now, these are just strictly memorization. There's no real rule or rhyme or reason why there's 4 oxygens and not 3 oxygens. So for this class, just memorize these. When you get into Chem 1520, we're going to introduce the other types of polyatomics, where this can change from a 4 to a 3, and it'll have a different name. So with that, these are the 7 polyatomic ions I want you guys to know. We're going to be using these in class. We're going to be using these all throughout the rest of the semester. So with that, I want to say have a good night, and I'll see you all in class tomorrow.